All right, 2x squared plus 9x plus 4 equals 0. Mr. Reagy, factor me up.
I need 2x plus 1.
2x plus 1 sounds like it's going to work to me.
And then x plus 4.
X plus 4 doesn't work, so I was wrong. What the heck? What do we got? Oh, no, that totally works. I'm totally wrong. Okay, good. Equals 0. So what are my roots?
2x minus 1.
2x plus 1 equals 0. X plus 4 equals 0. You got one step ahead of me. Let me catch up to you. Good job. And then x equals negative 1/2. Agreed?
Yeah.
That's one of them. And that's one of my answers, right? Everybody knows what that is. That's an answer to this question. What makes this thing equal 0? Okay, x equals
Plus 4.
negative 4. Now the problem is, we're about to start problems that are awful. I need to be a better guesser. I'm not going to go factor. Look at the problem at the bottom. It's x to the third minus 5x squared minus 15x minus 6 equals 0. I don't care how well you remember your factor patterns. You're not getting that one out of thin air, right? So I need to know where this negative 1/2 came from, this negative 4 came from. Can you trace them back for me, Mr. Reagan? Can you go backwards through these numbers and figure out, okay, so that 2, where did this 2 come from? Came from there, which came from there, which came from there, which came from there. So this 2 created a 2 on the bottom, agreed? All right. Where did this 1 come from? Well, this 1 was this 1, which was this 1, which was this 1. Where'd that 1 come from? We have to think about that for a moment. Agreed? What about this 4? Where'd the 4 come from? Came from there, which came from there, which came from there. So these 2 here, where do they come from? It's factors of 4, right? So the tops are factors of the last number. The bottom is factors of the first number. If I put a 1 down here, right? So factors of the last number divided by factors of the first number gave me my answer choices. Would that always have to be true? If I looked at this, is there any way the answer could be 7? And I'm going to close this door because I don't know what they're listening to. It's cooler than me, so that means it distracts me. Yes. Could it be a 7? Why not? If just looking at the top, could I have made this a 7? Any way I could make, there's no way to make a 7, is there? There's not, something that doesn't give me 7. It doesn't work, right? There's no way I can, there's just no way the factors can have a 7 in it, right? So it's always going to depend on factors of this divided by factors of that, which gives me a smaller number of choices to guess from. And that's important because we don't want to guess every number there is, because there's a couple of them. Okay? So let's go ahead to the next one. So now I'm going to do that's called the rational root theorem in case you want to be a math major. X to the third minus 5x squared minus 17x minus 6 equals 0. Happy place, happy place, happy place, happy place. Okay, so, Mr. Durr.
Yeah.
What are my possible rational, in other words, factorable answers? Factors of 6 divided by factors of...
Oh, it's the right one divided by the left?
Yes.
Oh, okay.
Factors of 6 divided by factors of 1. So what are my choices for factors of 6?
1,
1,
6,
6,
2,
2.
3.
Way to get those numbers in order. By the way, it's plus or minus, right?
Plus or minus.
Divided by, what are my factor choices for 1?
1.
Plus or minus 1. So now I'm going to make a complete list of every possibility.
Too many.
There's only 8. Wait till we get to 36 divided by 7. It's wonderful. It's a lovely experience. That's on the back side of the sheet. It's coming to you soon. So this is minor. So how many possibilities do I have? I have 8. One of them would be 6, right? So 6. What's another possibility? 3 divided by 1 would be 3. 2 divided by 1 would be 2. 1 divided by 1 would be 1. What else do I have? Negative 6. Negative 3. Negative 2. Now, later on, you can do yourself a favor if you do them in the proper order, like numerically speaking, because we talk about the intermediate value theorem. That's going to help us do some guessing. But right now, we're not ready for that. Okay, but I'm going to put them in order anyways. And it should be good practice for you to do so. Okay, I'm going to put a 1, a negative 5 up here, a negative 17, and a negative 6 right here. What are those? And I'm getting ready to do what? Synthetic division on an epic scale. We're going to do 8 synthetic divisions if we guess wrong 7 times. Here we go!
What if you like mess up? Because sometimes I accidentally.
Then you're going to find that what this chapter, what's nice is after you get a little practice, you'll know you messed up. Because how many answers am I looking for? X to the third, right? How many answers am I looking for?
3.
3,
Yeah.
right? 3. And then we're going to learn some rules by which sometimes we don't find 3. Right? We got to talk about those rules. We're going to get better at this. We're starting off raw. We're going, let's just guess every number. Well, okay, I'm only going to guess a rational one, so I'm going to guess this list. Okay? Then we're going to start narrowing it down more and more until we get better at this. Okay? So we're not guessing 150 numbers. We're just guessing the ones we care about. Good so far? All right, here we go. Which one do you want to get? Which one do you want to start with first? Guessing is going to matter. Don't look at the paper, Dirk. 6. You're going to start with 6? 6 is always going to be awful. Okay, 1. 6 gives me 1. Ooh, that's not bad. 6 gives me negative 12. Oh, that's really good. Negative 72, negative 78. Now, what did I do? Brought down the first one. 1 times 6 is 6. Plus negative 5 is 1. 1 times 6 is 6. Whoa. Glad I slowed down. Right? 1 times 6 is 6. Minus 17 is negative 11. Is that okay? Which means this is wrong too. Probably. Negative 11 times 6 is negative 66. Minus 6 is 72. Is this an answer? What? Is this an answer? Mr. Durr?
Are you going to drag those numbers down or you use the ones apart?
Hold on a second. What was your question? Let me answer my question first. And then I need to figure out what your question was. Look, if this is a 0, this is the answer. If this is a factor is x minus 6, then this would have to be 0, wouldn't it?
Oh, yeah.
I'd have no remainder. Do I have a remainder? I have a remainder, so this is not an answer. That's not the one I'm looking for. What was your question?
Are you going to... Actually, never mind.
No, I'm just going to go back to this. 1.
Oh.
So 1, 3 gives me negative 5, which gives me negative 2, gives me negative 6, which gives me what? Negative 23. Which gives me negative 69, negative 75. By the way, I would never start with 6 and 3 because those are high numbers. And I like little numbers. Do you like little numbers? I like little numbers. I'm a little weirded out though. Oh, they're not even listening right order. Okay, so then I put a 1 down here. 1, 2 gives me negative 3. Negative 3 gives me negative 6 again. Wow, that's negative 23. That's really consistent. Negative 46, negative 52.
No.
Let's do 1. 1 gives me negative 4. Negative 4 gives me negative 21. Negative 21 gives me negative 27. Wow. Let me check something really quick to make sure I'm not completely monkeying that up. Did I get the same answers they did?
Yes.
Double checking. All right. Well, we're going to move forward then. All right. Here we go. Put a 1 here. I get negative 1 gives me negative 6. 6 gives me negative 11. 11 gives me 5. That's interesting. Okay, that makes me feel much better about my answers. Moving forward. I got 1 gives me negative 2 gives me negative 7. Negative 7 gives me 14, which is negative 3. Gives me 6, gives me 0. Aha! Smiley face. I found one. X equals negative 2 is a solution, and X plus 2 is a factor. Right? Found one answer, and I found a factor. In case I wanted the factor. All right, I'm supposed to be at negative 3. 1, negative 3 gives me negative 8. Sorry, running out of space. I jammed this up. I apologize. Let me fix that better. Gives me 24, gives me positive 7. Negative 21 gives me negative 27. That's interesting. Didn't expect that, but okay, whatever. 1, negative 6 gives me negative 11. Negative 66, positive 66. Positive 66 is 49. Positive 49. Okay, and then 49 times negative 6 is something so awful it's hard to describe. What is it? Negative 300 minus 6. So negative 300 and negative 294. How's that? They got negative 300? Look at the paper. They got negative 300. How did I do that wrong? Negative 49. Oh, plus negative 6. I forgot the plus negative 6 part. You are correct. I am wrong. Thank you. Okay, I found one. Am I disappointed? Yes. What does that mean? There's only one rational root. What does that mean the other two are, Miss Tom? Irrational or, lest we forget, complex. Or the same, which is actually something that's it. Now, I want to point something out that's of interest to me. Here's the first hint for guessing. Ready for the first hint for guessing? Mr. Ray, we talked about the intermediate values there before. We said if there's a remainder above, remainder below, there has to be a remainder in between, right? Look what happened here. I have a remainder of negative 27 followed by a remainder of 5. Guess what's between these two? There's an answer between these two. But it's not rational. It's got a square root bar in it, so we're not going to find it today. But it's there. It's there. And then over here, I have something very interesting. It went from positive to 0 back to negative. My guess is the other one's right in here somewhere as well. It dips down and comes back up. It has to. Otherwise, it doesn't work. So it's going to be pretty close to this one right here. That said, this is early for that kind of thing. Does it make sort of sense? Okay. All right, with that in mind, go ahead and flip this over. Try problem number 1. Miss Tom, do me a favor and listen to me right now. Do not do number 3 as the third problem on the sheet. If you want to do it as the last problem on the sheet, you may go ahead. But it is by far the most interesting problem of the paper. Okay? All right.